Hello, this is John from TC Math Academy, and in this particular video we are going to solve this equation right here. Now, I really don't want to give you too many hints as I want to give you a full opportunity to solve this thing all on your own. However, I will say that I would like you not to use a graphing calculator. So do not use a calculator. Just use that calculator in between your ears, that supercomputer that we all have, and a piece of paper and pencil. But of course, the question is, do you understand this? Now, this type of problem, we're dealing with a level of difficulty that you would find like in an Algebra 2, college algebra, certainly a pre-calculus course. So if you haven't taken, math up to that point, then you may not know exactly how to solve this. Anyways, I'll fully explain this in just 1 second. I'm going to show you the right answer in a moment as well. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go and take a look at the answers right now. So here are the solutions to this equation. So we have plus or minus 2i and 2. So here we have a complex imaginary number as two solutions, and then of course we have 2 is a real number. Now, if some of you out there are looking at this and be like, oh my goodness, Mr. YouTube Math Man, I'm totally lost. I desperately need help in this. Well, don't panic. I want to explain to you kind of, obviously how to do this problem, and I'll give you some suggestions on how you can learn this. But again, you may not have taken this yet. And anyways, I'll give you more information on what exactly what I'm talking about in terms of the level of math that we're dealing with. But if you got this all right, that is very impressive. Matter of fact, you definitely earned a happy face, an A plus, a 100%, and a few stars. So you can tell your friends and family that you know exactly how to solve a drum roll. I'll tell you what this is. We are talking about a third degree polynomial equation. Okay, so the directions here would be find the roots of this polynomial equations, i.e. solve this polynomial equation. So anyways, I'll get into this right now in terms of fully explaining what's going on. But if you understood this, that's very, very good. Clearly, you are paying attention in your class, or maybe you've been watching a lot of my videos. Who knows? Let's get into the problem right now. Okay, so here is the polynomial equation in question. And the first thing we need to recognize is we're trying to find the roots to this. Now, of course, I'm telling you it's a polynomial. But let's suppose I said, just solve this thing, all right? And you're like, okay, no problem, I'll solve this thing. You would have to first determine what are you dealing with. Okay, there's different type of equations in algebra, and they're not all polynomial equations. You can have logarithmic, exponential, systems of equations, quadratic. Well, quadratic equations are actually polynomial equations, but there's all different radical equations, on and on and on. So not every single thing, of course, is going to be a polynomial. So you have to be able to recognize that, in fact, we are dealing with a polynomial. Okay, now polynomial will have terms in it. Okay, we have your variables right here, and this is just a real quick loose definition of a polynomial. Basically, you're looking at the exponents of the exponents on the variable terms. Okay, you can't have any negative or decimals. Basically, you're looking at positive whole numbers. All right, you could have zero. Yes, it's the positive. Well, that's the whole numbers. Okay, which includes, excuse me, 0, 1, 2, 3, on and on and on. These are the only things that are allowed in terms of your exponents, right? So, for example, let's suppose you had something like this, and this is important because you need to understand, one, that you're dealing with a polynomial. So if I have x to the 2/5 plus x squared minus 3 equals 0, this is not a polynomial. Okay, not, because this exponent up here is not a positive whole number. It's not an integer or positive integer, right? It's not 0, it's not 1, it's not 2. You got this situation, so this is not a polynomial, which means you'd have to use other techniques. But We love polynomials in mathematics and even more advanced mathematics like calculus. So polynomials is a huge topic that you study in algebra, pre-algebra, algebra 1, algebra 2, just continues on. So first things first we need to identify, yes, indeed, it is a polynomial. All right, so you can see I got all this crazy stuff written out here. Let's just talk about some of the things that you need to know about solving polynomials, polynomial equations. So the first thing is the fundamental theorem of algebra. So what does that mean? Well, let's go back up here real quick. And of course, this is not like a full lesson on this, but effectively what the fundamental theorem of algebra basically states is that whatever the degree, the highest power of your polynomial is, that's how many solutions you will have. So this third degree polynomial is going to have 3 solutions. Now, what type of solutions? You can have real and or complex type of solutions. So that brings us to our next thing. So you just don't know. You can have a real number or imaginary complex numbers. In this case, we see we have 1 real and 2 complex and imaginary numbers. Now, other things that you already should know about polynomial equations is just solving basic linear equations. So I'm talking things like 2x minus 3 equals 7. This, of course, is a linear equation, but it is a basic polynomial equation. It's a 1-degree polynomial equation, or polynomial equation, excuse me. And then later on, in like your first year algebra, you start learning about quadratic equations and all the techniques to solve quadratic equations, to include the quadratic formula. Okay, but again, this is a subset of all the stuff you learn about polynomials. All right, let's continue on. Next thing is graphing. So when you have the graph of a polynomial, you could basically get all kinds of clues to see what's going on in terms of the roots. Okay, so graphs are awesome, and you need to know how to graph polynomials. But we're going to refrain from graphing polynomials. We're certainly not, going to use our calculator, but you definitely need to know about this. And again, it's part of kind of the knowledge that you need to know about a polynomial. Now, here's some other things that are very, very important. We have, when you get into like more advanced algebra, okay, which we're dealing with right now, you start learning all sorts of kind of new theorems. Okay, one of which is the rational root theorem. There's other ones that you need to know about, and then here you got Descartes' rule of sign. We're not going to talk about this. We are going to use this, but these are just the tools that we have when we're solving polynomial equations. Okay, now if you really want to learn this kind of advanced stuff, I would suggest you either go to my Algebra 2 course, okay, which is effectively the same stuff you're going to get in college algebra. So that's going to take you one level of kind of advanced mathematics. But if you truly want to max out in terms of all the stuff you need to know about polynomials, I would strongly encourage you to check out my pre-calculus course. All right, that'll get into Descartes' rule of signs and all kinds of other good stuff. Okay, so if you're not familiar with any of this, well then, you likely haven't studied this yet. But if this is like ringing a bell, you're like, oh yeah, I remember rational root theorem, and yeah, I kind of remember something about it, then that means that, hey, you probably were taught this. But let's go ahead and get into how to do this problem. So the first thing is, of course I like to have fun with my little tablet here, is like some of you might be saying, wow, that's a lot of stuff to remember and keep, in mind. What do I even do? This is so confusing. Well, here's the deal, right? Learning something, like taking notes from a teacher, that's one level of learning. But it means nothing unless you actually do prompts and apply that knowledge. And the only way you're going to gain like full comprehension or synthesis of all these different concepts is to practice. Okay, so it is a lot of information, but again, that's why math, is cumulative, and it takes, years to build up this kind of knowledge. But let's go ahead and get into the problem right now. Okay, so here is our lovely third degree polynomial equation, and the objective is to find the roots. Well, in the roots, when you hear this word roots, you might hear another word, zeros, roots, and solutions. Basically, you're trying to solve this thing. You're trying to find the solutions to the polynomial equation. So, but all these words are very common: roots, zeros, and solutions. Right? Again, they're pretty much synonymous. And again, the first thing we want to do is like, okay, we know we are looking for three roots, right? Three solutions because of the fundamental theorem of algebra. I just don't know if they're going to be real numbers or complex numbers or imaginary numbers. You just don't know that right now. But you do know going into this problem that you will find three solutions. So that's the first thing. Now, the second thing is it's definitely nice to have the graph, okay? If you have the graph, if you're able to, let's suppose your teacher says, yes, you can use a graphing calculator. You definitely want to take a look at the graph because the graph can give you hints. Anywhere the graph crosses the x-axis are actually locations of real number solutions, real roots, okay? So the graph is like super valuable. So you definitely need to know how to use a graphing calculator, but we're not going to use this, but it is definitely nice to have the graph and to graph these things. But this is part of kind of like forming a game plan here. Okay, so the graph could definitely give us huge clues on where where and what type of solutions we have. Okay, but again, we're not going to use it in this particular problem. But the last thing we're going to be talking about here, and this is kind of, again, structuring our game plan to kind of tackle this problem, is using the rational root theorem. And this is a great starting point. So when you don't have any other kind of things that are obvious to do, most of your teachers or textbooks are going to say, just get right into the rational root theorem. Okay, so what does that mean? Let's go and talk about that right now. All right, so the rational root theorem, again, I'm kind of covering a lot of ground here that you need to look at this more thoroughly. But effectively, this polynomial equation, right, we know that it has three roots, okay? Now, what type of roots does it have? Again, we don't know if they're real number roots, they're complex or imaginary roots, but here's the thing. They may, or it may, not they, this polynomial equation may, and I'm going to really emphasize this word, may have, okay, some rational roots, rational roots. So what are rational roots? What are rational numbers? Rational numbers are basically numbers that are fractions that are made from integers, things like 1/2, 3/5, 6, right? Because you can write 6 as 6 over 1. So these are rational numbers. Hopefully you remember that, okay? But these are examples of rational numbers. So the rational root theorem is basically, it's a wonderful theorem, and it says, hey, look, this thing may have rational roots. It may not, okay? But if it does have rational roots, we can kind of make a list, and we're going to construct a list right now. And if this thing does have rational roots, it'll be amongst this possible list of numbers. So here's how this thing works, okay? So first of all, notice that our polynomial equation is written in standard form, highest to lowest power, okay? And our leading coefficient here is going to be q. Okay, so q, this variable q, we're going to assign as the value of this leading coefficient, which of course is 1. And then p is going to be our constant value, which of course here is 8. All right. So the rational root theorem says, okay, take the factors of p, which of course is 8 in our problem. Okay. You can see that right there. And the factors of q. So we're going to construct all the factors of p, and we're going to divide that over all the factors of q. And then once we kind of simplify this, we will have a list of all the possible rational roots. So the way you do this is the following. Okay, we're going to take 8 right here, and we're going to start with all the factors of 8. Okay, so what are factors of 8? Well, 1, okay, is a factor of 8. 2 is a factor of 8. 4 is a factor of 8. And 8 is a factor of 8. Now, if you've never seen the rational root theorem, okay, I'm just telling you right now, you have to put plus and minus into all of these, okay, because positive 2 times positive 4 is going to be 8. Negative 2 times negative 4 is also positive 8. So just get in the habit of putting plus or minuses for all your factors. That is our numerator. Now, again, if you're confused with this, just basically means that you need a lot of follow-on instruction. This is a lot in and of itself. So again, I'll just direct you to those courses I talked about. Okay, so what is Q? Again, Q is just 1. So the factors of 1, that's pretty easy, is plus or minus 1. Okay, so we can see that right there. So now let's go ahead and clean this list up. And here's how we're going to do this. We'll just take, we got only one number, or one factor down here in our denominator. So plus or minus 1 divided by plus or minus 1, easy. That's plus or minus 1. Plus or minus 2 divided by plus or minus 1, plus or minus 2. Plus or minus 4 divided by plus or minus 1 will give us a plus or minus 4. And then plus or minus 8 divided by plus or minus 1 is plus or minus 8. So what does that mean? Well, let me write this all out the long way. So 1, negative 1, 2, negative 2, 4, negative 4, and 8, negative 8. If this polynomial has rational roots, okay, it will be amongst this list, okay? And so this is obvious. This is great because we're basically saying is like, hey, look, one of these right here might be one or three of these might be our three solutions. Now, because it work out that none of these are solutions as well. Okay, so we just don't know. So what do we do here? Well, now we have to kind of start to try these solutions. This is the strategy that you need to take. All right, so let's take our list of possible rational roots, and here is the list. And we're going to go ahead and start checking these solutions to see, or check these possible solutions, excuse me, to see if we can find any solutions. Okay, so how do we do this? Well, this brings us to the next thing. And by the way, maybe I could put this way up on our lovely list up here. Let me go way up here. I told you I left a lot of things out. Over here, you could put in synthetic division, long division. So again, wow, that's a lot. Yes, I know it is a lot, but nothing that you cannot handle. All right, let's get back to the problem here. Okay, so now let's start checking these possible rational roots. So the way you're going to do this is use something called synthetic division. And the way synthetic division works is, notice again, we have our polynomial in standard form. We're going to take the coefficients. Okay, so we have 1, negative 2, 4, and negative 8. Okay, so here's all of this. And you can see we're just going to write them in this order. And they're going to make a little bracket, like an L bracket, just like that. Okay. So there's another kind of format that you can use, but this is the most common. All right, so that's step 1. So let's go ahead and check one of the roots right now. How about we check positive 1? So here is the procedure to use for synthetic division. So here you can see I already did the work. So I'm going to explain this to you. I know I'm covering a lot of ground quickly, so just make a note of what you don't understand, but here's how synthetic division works. Okay, so we always start with the very, very first number, 1. So we're going to drop that down right here. Okay, so you see that 1 gets dropped down to 1. Now, the next thing you're going to do is you're going to take that 1 and multiply. You're going to take whatever number this is and multiply by that number. So 1 times 1 is what? It is 1. We put the answer right here. Then we add down. So negative 2 plus 1 is what? Negative 1. All right, so hopefully you're following me on that. And then we're just going to repeat the procedure. Okay, so 1 times negative 1 is what? That is a negative 1. And then we add down. 4 plus negative 1 is positive 3. Okay, now we'll just continue on with the procedure here. So 1 times positive 3, of course, is positive 3. And then we add down, we get negative 8 plus 3 is negative 5. So this is a synthetic division, and this kind of gets into another concept here called the remainder theorem, right? So this is a whole, again, there's lots going on here, but here's the deal, right? If 1, okay, was in fact a solution to this polynomial equation, this remainder would end up being 0, okay? And obviously it is not. So what's this tell us about 1? Is 1 is not a solution. So we can throw that out. And so what do we do? Well, listen, we only checked positive 1. We need to continue to check all of these numbers. And you're like, boy, that's a lot of work. Yes, it is. But, you know, have fun with it. Okay, so we tried 1. It doesn't work. Now, just for interest of time, negative 1 does not work. Okay, so let's suppose we went on to our lovely list. Wow, that didn't work either. And then we went on to 2. So remember in the beginning of the video, I gave you the answer, and 2 was a real number solution. So we know that this is a solution, but let's suppose we didn't know that, and we're going through our lovely list, and now we run into 2. So we're going to try 2. So let's go ahead and do that right now. So again, we're going to start with this 1. We're going to drop it down. and then we're going to go 2 times 1 is 2. We put our answer here, add down. Negative 2 plus a positive 2 is 0. Okay, so we continue on. Whoops, whoa, I didn't mean to do that. So then we have 2 times 0, of course, is what? 0. Okay, add down 4 times 0, or sorry, 4 plus 0 is 4. And then we're going to just do this again. 2 times 4 is what? 8. And finally, when we add right here, we're like, oh, this is super awesome. Negative 8 plus a positive 8 is 0. And that means what? That means 2 is a solution, and we can celebrate. Yes, we got one. 2 is a root. Okay. Now, this is very awesome. Okay. And I'll tell you why. Because in algebra, if you recall, you got really good at solving quadratic equations, which are second-degree polynomials. So, you have techniques that guarantee you to find the solution to quadratic equations. Remember, if you use any technique and it doesn't work, you could always go to the quadratic formula and solve any quadratic equation. All right, so this is a really good find for us. So 2 is a root. So what does that mean? Okay. Well, effectively means that x equals 2. One of the roots equals 2, and that can come from, here's another topic, the linear factor x minus 2. Okay, I'll explain what I'm talking about here in a second. But more importantly, we have to go back to our synthetic division. And remember, here are the coefficients to our polynomial. Remember we had 1, negative 2, 4, negative 8? Well, look at the columns here. 1 was the coefficient of x cubed, right? Negative 2 was a coefficient of x squared. 4 was a coefficient of x. And negative 8 was the coefficient, or just the constant number. When you do synthetic division, whatever the answer is down here, the degrees go down by 1. Okay, in other words, instead of x cubed, this is now x squared. Okay, so this goes down by 1. Instead of x squared, our answer here is x, so 0x. And then instead of 4 to the first, this is now our constant. So really what we have here is x squared plus 0x, which are 0, or x squared plus 4. Okay, so that's what is the result of doing synthetic division by 2. Okay, we're talking about polynomial division here. So what you need to be able to identify is that we're talking about the linear factor x squared plus 4. Okay, we already have x minus 2 equal, because all this right here, if we had this and we set this equal to 0, we would set this factor equal to 0 and solve. We would get x is equal to 2, which we know is a solution. All right, so if you are with me so far, then that is outstanding. If you're completely lost, do not panic. Just be like, okay, I got to get more instruction on this, and that's what you need. This is not going to come, you can't just put a little bit of work in here and expect to master all this stuff. You really have to work hard to do this. You can do it. It's just, all based upon your level of commitment. Okay, so here we already have the solution to this. This is x is equal to 2. That's our positive root. So let's go ahead and now deal with x squared plus 4 and set that equal to 0. Okay, so x plus 4 equal to 0. Going to move the 4 to the other side. We got x squared is equal to negative 4. And you can see what's going to go on here. When I take the square root of both sides, right, to solve for x, I'm going to have x is equal to, actually I should put in a little positive or negative right there. The square root of negative 4, and the square root of negative 4, of course, is 2i. So we have that positive negative 2i. So of course we're talking about imaginary and complex numbers, right? So just to be clear on a complex number is written in the form of a plus bi. This is a complex number, okay? This component here is the real number component, and this component here is the imaginary number component. So, again, you don't want to be, you want to use these descriptions correctly when you're talking about the type of numbers and type of solutions that you're dealing with. Okay, so what does that mean? Well, it means we've found all 3 roots, okay? We've found 2. 2 is a real number solution. And how do we find 2? Well, we needed to start someplace. We used the rational root theorem, and we tested that, and we were lucky enough for this particular problem to have a rational root. And then what was left was a quadratic equation, okay, with imaginary solutions, and we have our positive 2i and negative 2i as the last 2 remaining roots. Okay, so I know I covered a lot of information in this video, but I would say that this is like an average level problem at this level of mathematics. So if you're like, what do you talk about? This seemed hard. No, it's going to get much more complicated than this, much more challenging. But again, this is nothing that you cannot learn. I don't care if you struggle with math your entire life. You can learn this stuff. Okay, you just have to make a decision that you're going to put in the respective level of effort. But I want to tell you right now, at this level of math, okay, you're just not going to just study a little bit and assimilate all these concepts. You really are going to have to put in the work, even if you love math, even if you're strong at math. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.